are literally shaping the planet.
Purpose is the only pathway to a regenerative future.
We have a choice to stay with the status quo or to change.
What is the point of trying to be just resilient when we can actually innovate?
Awesome. So I'll talk a bit more about our POCs in that time frame. That would be great. So without further ado, I'm going to share my screen, guys, and tell you a bit more about what we do and how awesome is automation in construction sites with marking robots. So first of all, my name is Tom Yeshurun. I'm the CEO and founder of Civ Robotics. We just went through a transitioning from Civ drone because we have more than just a drone. We have a sidekick Civ Dot ground marking robot as well that is laying out points with spray paint. We are automating land surveying services with emphasis on infrastructure projects. Why is that? Because infrastructure projects require a lot of land surveying services versus buildings, which require as well, but their magnitude and the pain of requiring, in a building you might require every 2-3 floors to lay out the job site or the floor plan, while in infrastructure projects, every day hundreds and even thousands of points are laid out, and it's not that pleasant. So a cool fact, actually a sad fact, that 90% of infrastructure projects are delayed, and that is due to many reasons. But the main ones that I think, which also apply in our case, is the shortage of skilled labor. There is a shortage of labor in construction, but it's far greater in infrastructure projects that are remote from the cities. So if you have a job site in Chicago, you have about 13 million people in that metropolitan who can work force, and there's a lot of people, subcontractors, who can provide that service. But if you're in the middle of nowhere, let's say 3 hours from Austin and 2 hours from Midland, you're literally in the middle of nowhere and you have to build a solar farm. You actually have to bring people there, lodge them in hotels, provide them support to deploy your operation in these construction projects. And we are human. People make mistakes like marking mistakes. It could be a scribbling number that was not really clear on the actual stake. It can be off by an inch just because the person drifted a bit with his hand when positioning the stake. Or it can be even writing things incorrectly physically on the stake itself, or feeding the information incorrectly from the blueprints. And these cause reworks. Reworks is a big pain in our industry, and we do our best to avoid that. And that's one of the main reasons for causing delays in job sites. And I also mentioned this earlier, instructions are just not clear a lot of times. Projects get, blueprint updates and things change, and they have to convey that information in the job site. So the main job and role of surveying in construction projects is to show the blueprint in the real world, and they do this by putting stakes in the ground and spray paint. And they just hate doing this. It's so tedious. There's so many details you have to do. Sometimes it's very repetitive, like marking, in this case, 20,000 piles for a data center, or reading the information from the stake that I said also earlier. What does it mean? C minus 2.3. It might be center line. It might be cut. So people have this Morse code in order to convey the instructions, and we try to avoid misinterpretation. And by making it digital and clear, you just won't make a mistake because of that. So without further ado, I'm going to show you how we automate this process with the vision and goal to automate the entire layout process in order to shorten project timeline, because this is a critical path activity, meaning that if we shorten this activity, we shorten construction project. And by doing this with less personnel on the job site, while increasing profit, de-risking project delays, de-risking safety issues as well, it's a great benefit. So we're first going to start with our staking drone. That's our first product. So here you're going to see on the left our software, our mission planner. The drone flies autonomously to the desired coordinate. this whole thing is autonomous. It lands above the desired coordinates, slows down the last 3 feet to ensure accuracy of landing. And as long as we land within 4 inches, on the left, you'll see the point number 1 becomes green because we landed close enough. We load a stake from the magazine, and our marking mechanism that takes into account in the algorithm the terrain condition and the rover, the drone itself, orientation in the world, makes a marking correction to achieve that 7-inch accuracy. And a lot of times people say, how do you do this? How can you measure you? So we had a surveyor lay out that point beforehand with spray paint. And we're going to see in a few seconds how precise we have. We use the same technology as surveyors use today, but instead of guiding the people where to walk and mark the stake in the ground, it guides the robot. And we're also penetrating hard soils, in this case asphalt, by making a pre-drill hole and later loading that stake from the magazine and placing it in that pre-drill hole. And using our unique stake design, the threads actually melt into this soil, and it's becoming like glue, very cohesive, and it doesn't come out. And because we've deployed this in various job sites, we saw another need for Civ Dot, because a lot of our customers wanted to lay out, points that are real close to one another. So in this case, we use it for marking points, as you can see on the left. And then our customer said he wants to use this for striping, to mark where to do the striping for this road closure. So I was like, do you want me to just do the whole line for you? It's like, wow, that's possible. I'm like, yeah. So we did it. So we literally did his stripe. In this case, data center, 10,000 points, 10 by 10 grid. We got, again, 10 points per minute with this ground robot. So it drives from one corner to the next, slows down as the cheat gets close to it, and ensures that it parks right above it within the tolerance that the client desired. Another great use case is solar farms. Again, coordinates are really close to one another. In this case, usually no more than 20 feet. Have Civ Dot, we can slow down, see how it does its fine tuning to achieve that 7-inch accuracy. So we have Civ Dot lay out the point with spray paints, and the person walk behind it, hammer take it to the ground. By doing it this way, we're not changing the process. We're not changing the end result, which is having a stake in the ground within the accuracy. And we've done a bunch of job sites, pilots, and POCs with customers. And one of them we deployed, this was about 15,000 points. And we found out, and we extrapolated that if we would have done the entire job site, it would have taken us 10 months to do so with one operator. That would have cost in total $500,000. Well, today it cost them $2 million with 4 crews. That means 8 surveying professionals out in the desert versus one operator. That means almost or more than 100 months in the field versus 10 months. And the quality, like I said earlier, is better with automation. Less than 2% of our markings were off than an inch. While with this manual surveying, it was about 4%. And because we do this automated, we can provide real-time updates and automatic reports. We also saw benefits of other tasks in productivity. Just by being able to visualize the entire blueprint at real scale, we can have higher outputs. In this case, trenching. Instead of doing a point in that same solar farm every 60 feet, I told him I can do that entire line. And then he dug it much faster. And the end goal is to finish construction sooner rather than later at lower cost. And I already mentioned this earlier, we are digitalizing these information. So no more hand scribbling on the stakes. The stakes are smart, which means there's an NFC chip. You can take your phone, just touch it. Just like you pay for your drink at Starbucks or whatever preference you have. And then instructions pop up very clearly. If it's filling sand, what's the depth? If you install a pipe, what's the depth? What's the offset? what is the description of that pipe? Is that PVC 20 centimeters or is that 30 centimeters? All this information is very clear on your phone versus having a scribbling Morse code on the stake. And right now we're focusing on a few segments in the market. Renewable energy at first, solar farms and wind farms that require thousands of markings to be done every day. In solar, it's mainly the piling work and the trenching, while in wind farms, actually access roads. So it's basically is about, for every 3 turbines, it's about 1.5 miles of access roads. And for roads and rail, that's the next sector we're already deploying our technology at, for laying out the earthworks and final elements, including paint as well. Ports and pipeline, it's very similar to data centers, is mainly for piling and very open spaces with a lot of different markings for different systems. And like I said, we already deployed our technology with a bunch of clients in the US and also in Japan. We've had 8 paid pilots, we have 2 purchase orders, and we have 2 more longer POCs in the US. We've done already 75,000 points, and we're looking to do a lot more this year and the next. And our business model moving forward is very straight up, very straightforward. You have a set of costs when you start as a customer. You have a month of lease for our systems, and you buy our consumable stakes. $1 for a simple stake for its solar in various colors, and $2 for smart stakes. But for now, we're providing this as a full service for paid pilots and including operations. But moving forward, you'll basically get an immediate ROI on these investments because you have less people on your job site, lower costs, finish faster, and the down payment here is less than 10 grand. There's other products out there who are attempting to solve this problem inside the building. Some of them are maybe even here in this call and probably presenting later, which I have, great, I respect them very much, but we're working in very different terrains. Civ Robotics is doing this inside a building with a robotic total station to achieve millimeter level of accuracy, which is great, but it's not necessarily outdoors. And that robot cannot really perform off-roading. Tiny Mobile is doing something similar in sports field and roads. Again, nice paved roads, not able to perform in rough terrain like we do. And the land surveying equipment, which is done by Trimble, Leica, and Topcon, which are probably brands that you all know, have 2 basic systems that are used today. Handheld GPS, those very fancy antennas that people hold in their hand walking around the job site. They're very, they're built to work in outdoors in any terrain basically because you're manually walking around with this antenna. But the level of autonomy there is close to nothing. In total station, those tripods, total lights that we all see and probably had to experience in our early days in our career, are far from autonomous. So that's why we have the robotic total station. But again, you have to move the tripod from a known place to the next, all over the place. And then when you work outdoors in infrastructure projects, we're talking about miles, not feet. You have to move in the system over and over, so it's not that autonomous. So I'm here for more information. You can reach me at tom@civrobotics.com, and I'll be happy to answer any questions you may have and show you some more videos because there are a lot of questions you probably have regarding the operation itself. So Nick, I take it back to you, I guess.
Yeah. We have about 15 minutes left. Tom, if you want to open it up for any questions from the audience, I think that'd be a great way to spend the time. I did see a couple come in. I don't know if you had a chance to see those, but yeah, if you click the Q&A box.
See them in the Q&A box. It's kind of weird. Or chat right here.
I think it's in the Q&A box, yeah. If you can.
Oh, yeah. Awesome. Yeah, I see it here now. So great question Eric asked is about, can you spray lines for excavation for foundations? Yeah. There's no difference between spraying lines for anything. If it's a point or a line, in terms of the robotic system itself, we have that feature as well. It's literally as if like there's two coordinates, just straight between them. So do you activate before, or do you activate the system when you stop or when you drive? So yes, you can do lines, no problems. And the level of accuracy is the level of RTK, so the same level of that GPS that we use. And which brings me to the next question that was asked. What is the level of accuracy? The level of accuracy that we can provide right now is the same level of accuracy of our RTK devices, which is within sub-inch. The further you are from a known location, the less accurate you become, but that's the same problem with every GPS. So we add about 8 millimeters, which is about a quarter of an inch, to whatever RTK that we deploy. And right now we're using a really great off-the-shelf RTK with about 10 millimeter accuracy. So we're within 3/4 of an inch in ideal conditions. So that's why I say sub-inch is the level of accuracy of our systems. We are testing a Trimble integration as well, and which will most likely be more reliable in that way. But in terms of quality and accuracy, it's been very stable since we've deployed with our existing RTK.
I see two questions in the Q&A, Tom. Both are from Matt Wheelis. So he says, do you see stakeless civil work, AMG, as a challenge to your business model?
That's a great question. So for some reason I can't see this Q&A doing this, so thanks for bringing those up.
Yeah, no problem.
So
Doing my
yeah,
job.
so on one hand, I see that there is shifting that direction with earthworks, but a lot of these job sites have tried machine control and failed. For instance, solar farm piling, the outputs actually went down. That's why they moved back to laying out with the whiskers, which is one of the reasons why we're focusing on that market right now. But moving forward, we do see other benefits of integrating our smart stake to this autonomous machinery, which we're in touch with other companies in this space to integrate that. What's a stake in the ground? It's a known point. What's a known point? It's an X, Y, and Z that you can see and visualize, and you can also triangulate by making a local grid. So yes, in heavy civil, especially in mining, I'm not even touching that market because machine control is great there. But in other places where the accuracy is far more important, that's where we still have a good market to be at, and we can add more value to our customers with conveying information for different subcontractors. So, for instance, in piling, there's a few applications there, and railing machines. Like, there's so many different people on that job site who can use that same stake, while the alternative is having all machines machine control, and it's a big investment for many of these contractors. So on the bigger projects, I agree that there's a great application there for machine control. And even though they still validate with GPS systems, we actually are deploying our Civ Dot at a job site with machine control for piling because they want to use our markers for shakeout before they do the piling with machine control, and use our spray paint for quality assurance to like a double check. So we see more value in that, providing that data as early as possible. Another great benefit of using the classic system is that when there's no reception, machine control can operate, but our stakes are already there, so then construction can continue. And in remote places, this happens often, and the quality is vital in that sense. So being able to lay out those points as early as possible, and those points can stay there for a good amount of time, basically empower contractors to work more days on the job site.
So the second question from Matt, do you see an opportunity for data collection, grade checks, et cetera?
Yeah, so that's a great, a lot of our customers have already asked that question. The biggest data that we're collecting right now and providing that as early as possible is the altitude of the soil especially in solar farms. By knowing that altitudes before piloting, we actually reduce the amount of reworks because we can tell them at a time that they might need to change the pile type. Because right now, the pile machine comes in and starts hammering it. And they don't know the elevation until they start hammering. So if it's a significant change between what they know when they design it, because they usually scan the job sites with a lot of vegetation, they don't really know if it's 3 feet, 1 foot, or 6 feet of vegetation. That's a great benefit of having that data as early as possible. And the second, which I think will be the most data that we collect and integrate, is our Smart Stakes is an open API, which we hope to integrate to other project management tools such as Procore and BIM 360, PlanGrid, and whatnot. Basically digitalize the entire process. So let's say a pipeline needs to be installed. So there's, let's say, 3 entities in this process. Digging the earth, installing the pipe, and covering it up. When the earth work is done, that basically contractor, subcontractor presses complete. We log that. We update the PM or whoever superintendent needs to know about it. You get a notification. If a quality assurance needs to go validate that, can also get a notification. By connecting the real-time updates from the field with our Smart Stake, we can empower contractors to be more transparent about the work that's being done and basically shorten the downtime between subcontractors. So that role is done. Now the subcontractor for laying out the actual pipe itself says, go lay out that pipe there. So the data on that stake now changes, and we know that subcontractor got notification on let's say Tuesday, and he didn't touch that stake until the following week. So the next day we can say, why haven't you gone there? It's more of a monitoring tool for the project management. And by integrating that data, we can basically have more transparency and better results and better quality.
Great. Tom, I saw one come in. Carson asked another question. So how are you closing the loop between as built versus as designed, kind of versus, physical versus digital data?
So we don't do as built right now because if you look at our system right now, there's no cameras on it even. We are doing the marking while others are doing the measurement. So I'll give you an example. There's other great drone companies out there I can, recommend using, anyone from Pix4D, Drone Deploy, Skycatch, and Propeller, who can validate what was done after it was done. But we show them where to build. We show the client where to build, to avoid having those issues that arise later. So the more we mark with more details, the less mistakes will happen. And as construction projects become more and more complex, there's more need to mark more things, which is where we see the value. Because construction, let's be honest, hasn't developed and evolved as fast as design. We have these beautiful infrastructure and all these detailed elements, but the methods haven't evolved as fast. So there's actually need for more markings because there's more things need to be done with precision. So we need to mark more points better, to avoid having those mistakes later. And based on our customer discovery, during construction, the land surveying role is between 70 to 80% marking and 20 to 30% as-built. And we're trying to focus on that side right now. Some of the customers are actually asking us to create a mount for camera, for 360 camera, for whatever software they want to use later. I say I don't mind as long as it does not interrupt with our marking mission itself. We do see the value of collecting more data for monitoring and for maintenance, but for now that's not our focus because we have to focus on doing what we do best, which is basically laying out the points as fast as possible and as many as possible.
Great. I do not see any other questions. Audience, do you have any other questions for Tom and what he's doing at Civ Robotics?
I will add a few more, things that people usually ask me about our drone and our ground robot. Start with a ground robot. It can lay out up to 600 points continuously with one spray can, or 250 yards with one spray can. Battery life swap once a day, which is very low maintenance in that way. The drone, though, is a bit more complex. It does require a certified drone operator to handle. It can fly up to close to 30 minutes, which is equivalent to up to 40 points in a row, because like you saw in the video, a lot of the time we spend it on the ground and not flying. So every 40 minutes, you change the batteries and stakes with magazine. And moving forward, which we're going to deploy probably in mid-2021, a ground staking robot as well for our customers starting in solar farms.
It sounds outstanding. Well, Tom, very excited to see your progress in the coming months and years, and tell this to all entrepreneurs building tough solutions in the space. Really appreciate you committing to sticking with the industry, and you're pushing the ball forward, I think, more than you know. I think it's easy to forget that on a day-to-day basis, but appreciate all your hard entrepreneurship.
Thank you so much. I appreciate, love doing what I do, and hope to bring more innovation to companies out there, wherever you may be. We're deploying in anywhere from Oregon to Delaware and anywhere in between. We're heavily right now in Texas and in California, and we're looking forward to deploying more and more job sites in the U.S. and also in elsewhere if there's a big need for that. So I'm looking forward to deploying more systems out there. Thank you for this.
Great. Thanks so much, Tom.
All right. Bye, guys. Bye, everybody.
See ya.